That's what happens when you don't communicate, or you don't communicate where the teacher can hear you.
Next time I'll yell at you.
Mm-hmm.
Mm-hmm.
This is spring break for my kids. This is the first time I've had Thursday night to myself. Usually on Thursday nights, I'm having to hurry up and eat and give everybody dessert. I cook and I give everybody dessert, and they're all in there eating dessert while I'm having to deal with y'all. This is the first night I don't have everybody over at my house right before class. And the other 7.3 is the same curve. So you better make sure you do a lot of copies in this chapter, because you are going to do a lot of bell curves. 100, 120, 140, 160, 80, 60, 40. So these are the three types that you're going to see in these sections.
0, 1, 2, 3. 1, 2, 3.
And this is base, and this is height, and we're going to get to that in just a second. I'm just giving you a rundown of what we're going to be doing.
100, 120, 140, 160, 80, 60, 40.
Miss Honey, where did you say you lived? What? Do you live in Anderson or Oconee or Pickens?
It's the Anderson side of Fairplay.
Oh, I'm very familiar. You used to do a lot of surveying up there.
Okay.
Yeah, y'all got a Dollar General in the last 5 years. Y'all
That's
doing
right.
good.
There's 2 truck stops and a Dollar General, and that's about it.
And Yoder's, don't forget Yoder's.
Yeah, that's true.
Yoder's is like y'all's Walmart.
Basically.
Yep. I used to do a lot of surveying up there, and my uncle has a dairy farm right there at Townville and 24 and 85. And we used to go up there a lot to do a lot of surveying. And
that's your uncle?
Well, he's dead, but that's my family, yeah.
Oh, okay.
And that's a nice place to live up there in Fairplay. The only problem is you either got to go to 24 Ingalls or Seneca to get food. That's the only bad thing.
That's true.
But now you got the Dollar General, and Dollar General is like Walmart there. All right. So anyway, this is what you're going to see. So how many of these are you going to see on your test? You're going to see 2 of these, 1,000 of these, and 1,000 of these. I'm just kidding. You'll probably see 2 of these, probably 3 or 4 of these, and 3 or 4 of these on your test. The rest will come from 6.1 and 6.2. Okay? Which will not be Philadelphia lawyer questions. It'll be the questions that I say are good questions. All right, so let's go to uniform. Let's do uniform first. The uniform questions will be as follows. They will give you a sentence like, the teacher has a what is the probability that he goes over 45 minutes? I don't know. Minutes, they don't look right.
Yeah, it's right. It's spelled weird.
All right. So you draw a curve. I mean, not a curve. since it's time, it's a box. And you put 0 right here. And you put 50 right here. So we can all say that the base is equal to what? Minutes. And the height is equal to probability. Now I'm fixing to write in red, and I'm going to write on this page right here. All areas under curves is equal to, somebody tell me.
1.
Good job. Now, I wrote 1 with 4 decimal points. There is a reason I do that. I do that because when I teach chapter 7, I like to tell students if they see 4 decimal places, that means we're talking about an area / probability / percentage. Okay, depends on what the directions ask for, but it's all the same thing. If you see 2 decimal points, that is going to be a z-score. So since the area under all of these curves are 1, I put 4 decimal places on that 1 just to make sure you understand that that's area. That's the area under this curve. The area under this curve. And the area under this curve. Now, some of y'all may say, well, Hubert, I thought it was 100. You could say it's 100, but that's when you're dealing with percents. Okay? And your empirical rule, the empirical rule that we use, it has it in percents, and I understand that. But you can change, you can change all those percents to decimals in a heartbeat. Okay? So it's the same thing. It's just 1 is percents and 1 is decimals. All right, so I can go ahead and put the area in this rectangle is 1.000. Now we're going back to pre-algebra. Area of a rectangle is equal to base times what?
Height.
Times the height. We know the area is 1.0000. The base is 50 minutes. And the height, we don't know. So with a little bit of pre-algebra, how do you undo to multiplying by 50? Divide by 50. So H is equal to 1 over 50. And I'm going to put that right here. 1 over 50. That's the height. Okay, now I'm going to highlight that height. And I'm going to tell you that sometimes you have to calculate it. And sometimes it's given. Sometimes you have to calculate it. And sometimes it's given. So you may do a homework problem in 7.1. And they already got the 1/50th beside, and all you do is the next step. The next step is what they ask you to do. Now, it says, what is the probability that he goes over 45 minutes? Well, 45 minutes. 45 minutes is right in here. So I'm going to highlight that in pink. I'm going to take a pink highlighter. Let's go. That's 25 minutes right here. This is 25 minutes. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And I'm going to take a Well, that's 45. Now I want you to tell me which side am I going to shade of 45 if I'm talking about more than 45? If I'm talking about more than 45 minutes, what side am I going to shade?
The right side.
The right side. So I'm going to shade, and that's the area that they want. Over 45 means they want this area right here. Now it'll make more sense when we get to the curve because you're used to seeing the area under a curve. All right. So somebody tell me, what is the area for a rectangle? Well, we said area of a rectangle is base times height. Area of a rectangle is equal to base times height. Area is what we want. Somebody tell me what the base of our pink triangle is.
50.
Now be careful before you blurt it out because you got to look at it. I'm going to check the, hold on, while y'all are looking at it, I'm going to check to make sure. Is that better? That's a little bit better focus-wise, isn't it?
Yeah.
Okay. All right, somebody tell me what is the base of this pink triangle or rectangle?
Is it 5?
5. 5 what? 5 minutes, but you don't really care about that. And then what is the height of the pink triangle?
1/50.
1/50, and I want y'all to do that with your basic math skills. That's 5/50, which is 1/10, which is 0.1. So the area of this pink shade is 0.1000. I didn't have enough room to put the extra 2 zeros. So you could say there's a 10% chance that he's going over, he's going over 45 minutes. You can say there's a 0.10 probability that he's going over 45 minutes. You can say the area in the pink region is 0.1000. So do you see where the probability and the percentage and the 4 digits, they're all the same thing. Okay, it depends on the context. All right, who's got a question on that one? You're going to get 2 of these on the test probably. And they're going to be exactly like this. Except they may give you the what? They may give you the height. Let's go look right quick. Let's go to our handy dandy homework in 7.1. My labs math. Y'all have to excuse me. I wasn't able to get everything ready before class. So here we go. 110, 111, 12011. And I'm going to go to 7.1 because chances are the time questions are in 7.1. Because in all probability courses, that's where it's taught before the curve. Let me find one. And usually they're a dead giveaway because there it is. Yep, look at there. They give you, let's do this one. So that way you can at least do one on the homework and you don't feel like a failure. There you go. All right, I want y'all to read it. I want y'all to set it up. Graph to the right is a uniform probability. This is a test question. Who is X minutes late? Find the probability that the friend is between 20 and 30 minutes late. And then it is 10 a.m. There is a 30% probability the friend will arrive within how many minutes? So go ahead and write everything down. They give you the height of 1/30, so you don't have to do that. All you have to do is find the area between 20 and 30 minutes.
Can you blow it up a little bit?
No, Diva.
More like blind ass old woman.
I can't do no more
That's
because
good.
it takes away the.
Yeah.
I'm gonna have to take it down one notch. I can't.
Okay.
There, that's as far as I can go.
That's all right. Did I say densely? Probably densely?
Density. The height is density. I don't know.
Uniform probability density.
Yeah. Find the probability. That's all you need to be able to do. Okay. So I'm going to draw mine while y'all are still working. And then I'll put it up on the board. So we've got 1/30. And we've got 0 to 30. So 5, 10, 15, 20, 25, 30. 5, 10, 15. I like to graduate mine, so I'm weird. 5, 10, 20, 25. Okay, so this is all we need right now. It says A, find the probability of the guy being between 20 and 30 minutes late. That's the first question. So let's attack that one first. Here's my picture. Okay, Mr. Mance is going through his let's get the class dizzy.
He
So
doesn't have his video on.
Huh?
He don't even have his video on.
Yeah, he does.
Well, I can't see him.
There's 3 people with videos on. You, Miss Honia, and Mr. Mance. You have a different view. That's why you got to go down to the Teams icon and pick the other view, or you got to go up to the 3 dots and change the view to gallery. That might be it. I don't know. You've got a different setting on your Teams.
No, it's on gallery.
Can you see Miss Honia?
Yeah.
Huh. Well, I wonder why you can't see Mr. Mance. He does have his video on. All right, so here we go. I'm going to take my pink and I'm going to highlight between 20 and 30 minutes. All right, somebody tell me what the base is.
Will be 10.
10 is the base. The height is 1/30. So the area of my rectangle is equal to 10/30. Which is equal to 1/3, which is equal to 0.3333. Or you could say there is a 0.33% chance that he's going to be 20 to 30 minutes late. Or you can say the probability is 0.33 that he's going to be late. So that's the 3 contexts. You've got area. You've got percentage. and you've got probability. Area and probability is pretty much the same.
So how do you know your base is 10? Because you go, that's what I'm trying to figure out. How do you know your base is 10?
What do you mean?
Well, you said your base is 10, so tell me how you know your base is 10.
What's 30 minus 20?
I got you.
Got it?
Okay.
All right, now let's see what the second question says. The second question says, it is 10 a.m. Okay, this has nothing to do with 10 a.m. There is a 30% probability the friend will arrive within how many minutes? Well, let's say 30 is 0.3000. So I'm going to go down here and I'm going to write, they say, this is part B, 30% is equal to a percent, which means I can turn that into a what? An area. Area is 0.3000. And that's the area. All I did was move the decimal place 2 places to the left.
30%, which is equal to
0.3000 area.
0.3000 area.
So if I know the area of a rectangle, I can plug that into the A and use the height to figure out a new what?
Base.
A new base. What does the question ask for? It says it is 10 a.m. There is a 30% probability with how many minutes? Within how many minutes? So I need base. So I'm going to plug and chug and get a new base. So here we go. I'm going to plug 0.30 or 0.3000 into my area formula. So area equals base times height. So 0.3000 is equal to base times 1/30. Now, how do I get rid of multiplying by 1/30?
Divide it.
I divide by 1/what?
30.
30. And I divide this by 1/30. Now, if you want to change 1/30 into a decimal, that's fine. I don't care how you do this. Okay, you do it on a calculator. I'm not gonna split hairs with you on how you do this. So I'm going to take my calculator and I'm going to take 0.3. Hold on, let me make it small. Here we go. I'm going to do this calculation right here. Clear. 0.3000 divided by parentheses 1 divided by 30. I told you I wasn't going to, you do however you want to. Now you could multiply by the reciprocal, which would be 30 times 0.3. You could do that. However you want to do it is fine with me. I get 9. So that's 9 minutes. B is equal to 9 minutes. So if they're supposed to meet at 10 o'clock, what time is Butthead going to get there?
Hang on. 0.3.
10:00 what?
10 o'clock.
10:00 what?
My calculator must be really freaking off because it's telling me that
10:09.
Y'all aren't paying attention. Go ahead. What would you say, Miss Kidd?
I did the same exact thing that you did on your calculator in my calculator, and it gives me 0.01.
And you use the parentheses.
And I used it. Look, I did.
You didn't put a division symbol between them.
Okay, let's back up then.
Okay.
Parentheses.
All right, let's look at the question because this is
Okay.
where you're missing it. When I told you wasn't paying attention, I think Mr. Mance, What does it say? What time did you meet? What
10
time
o'clock.
are you supposed to meet?
10 o'clock.
Or it is 10 a.m. There is a 30% chance that Butthead will show up at 10 what?
30.
I don't know what I'm going to do with y'all.
10:09.
10:09. Because you got a 30, he's going to be 9 minutes late. So that's going to be 10:09. Now, I don't know if they want 10:09 or if they want 9 minutes. Let's go type it in. All right, A we said is what? 0.33. Says round to 3 decimal places. 0.333. Free. Nothing is free.
I
Check.
didn't see how you worked out that BX times 1/30 divided by 1/30.
9. They just want 9. Okay, now what's your question?
I didn't see how you worked the second part of that out. That
There it
BX. No,
Right.
not that one. The BX times 1/30 divided by 1/30.
There it is. How do you get rid of multiplying by 1/30? It's algebra. How do you get rid of multiplying by something?
Turn to decimal?
No, how do you get rid of multiplying by something?
Do they cross each other out? They cancel each other out?
What is the opposite of multiplication?
Division?
Division.
So the opposite of multiplying by 1/30 is to what?
Divide by 1/30.
And that's why I divided by 1/30. If you do it on one side, you got to do it where?
On the other.
The other.
But where did you don't get an answer for the one?
That's what we did in the calculator, right here.
You did the B times 1/30 divided by 1/30?
Yeah, and what's 1/30 divided by 1/30? See, the dog knows. The dog's answering.
Dally, shut up!
Kicker.
I got one. That ain't right.
I'm kidding.
I don't.
So what's 1/30 divided by? What's anything divided by itself, Miss Kidd?
1?
Yeah. So you get 1B is equal to this answer.
What do you
That's
do
it.
with the 1B?
Well, divide by 1.
And you end up with
What's-
B is equal to
What's any
9?
number divided by 1? Same number. So your answer is 9.
B is equal to 9.
9 minutes. Write down 9 minutes. So you won't forget when you go to the question, you'll know what it's asking for. 9 minutes. So if you meet at 10 o'clock, this joker is going to show up probably by 10:09. Everybody good? Okay, now let's move on to the meat. Let's move on to 7.1 and 7.2. Now, 7.1 and 7.2, you will use, and this is red, you will use the empirical rule as an estimator. And I don't know if it's OR or ER. It might be an ER, one who estimates. That'd be an ER. Okay, what does that mean? That means that you're going to use the empirical rule, what you remember about the empirical rule, to estimate your answer to make sure that when you do the answer in the calculator, it doesn't be way out in left field, okay? So you're going to use the empirical rule as an estimator for 7.1, for the bell curve type questions. All right, so here's an example of a question you're going to see in the mu is equal to 0, the standard deviation is equal to 1. Remember I told you, this is the second type question you're going to see.
All right. Let me catch up.
Right here, see? The second type question is right here. So I'm going to draw a curve. And I'm going to, and that's why you need to have those copies that I told everybody to do, and only like 2 people did them. This is why you need them, because you're going to be doing one of these for every single problem. And I'm going to pull up a homework problem, and it's going to have 4.
Oh, shit.
So you need to print them out. 2, 3, -1, -2, -3. Now I'm going to put my numbers in here for you. That's 0.15, and everybody should know what these are. 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. I ran out of my big curves, and I don't like these, so I'm not using them. I'm going to have to print out some more. Okay, and of course, the green is going to be 2 standard deviations. So there's 1, 2, and there's -1, 2, so that's 2 standard deviations. And we all know that, just like we went over the other night, that's normal. And that's 95% by the empirical rule. And then we know that the outside edges are called unusual. Whether you're talking about unusual or outliers, they're both unusual. Okay, this is what you should have on every single copy that you run. You don't have to have the green. That's up to you if you want it. Remember, I gave y'all one that you could print out that was highlighted. Okay, you can use that if you want to. Yeah, there they are. You can use that if you want to. All right, the whole point is get a bunch of these, because in just a minute, we're going to do a homework problem, and it's going to have 4. And you're going to have to be very resourceful on you doing it all on here, because it's going to be a mess. All right, now I'm going to give you an example of what you're going to be doing. I'm going to say, what is the probability and probability can mean what? Area or percentage. In this case, we want area. Above or greater than 1.2. Now, the first thing I want you to do is I want you to plot 1.2 with a color that you like. And then I want you to shade the area where you think is greater than 1.2. I want you to plot 1.2, and then I want you to shade what you think is greater than 1.2. And I'll do that in a color orange. Yep, that looks right.
It's all in pink. I don't have very many
1.2 is
highlighters.
right here. So I'm going to shade everything to the right.
Smoking.
Now I want you to take the empirical rule, and I want you to tell me what you think this percentage is. Take the empirical rule, and that's going to be 0.15 plus 2.35 plus, let's see, 13.5, and this looks like 1.2. I'm going to say, what, 11 or 10? Okay. So I'm going to get 5 and 5 is 0. 3 and 1 is 4. I moved to 5, sorry. And 2 plus 11 is what? 13? So by the empirical rule, I'm saying that this orange area is around 13.5% or 0.1350. Everybody with me? I need you to tell me if you don't understand, because this is an estimate.
Is that what those little squiggly lines mean?
Squiggly with a dot on top, that means I'm estimating, approximating. Now, somebody tell me
Why
what
did
this,
you wait? Tell me again why you moved the decimal 2 places to the right.
this is a percentage and this is a probability or an area.
Lord. Okay, so
You just move the decimal 2 places to the left. You'll get used to it. Don't worry.
probability and what would you call it?
This is a percentage. This is a percent. I'll write a percent there. There you go. And then I changed it into a area with 4 digits. Yeah, or probability. Okay. Somebody tell me what this arrowhead's called right here.
0.
Nope, there's 0 right there.
No, it's continuous.
Yeah, but how do we say that in mathematics? Which infinity, Mr. Mance?
Negative.
Negative infinity. So I'll give you $1 if you know what this one is. Positive infinity. But guess what? We can't put infinity in the calculator. So from now on, from here on out, this arrowhead is called negative 9999. And this arrowhead is called 9999. From now on, if you're coming from this direction, we're going to call negative infinity negative 9999. Can you do negative 12, 12, 12, 12? Yeah. Can you do negative 1,546,000? Yes. Anything above negative 3, you can use. But I would use something big like negative 9999. This is positive 9999. Now, I'm going to go down here. On your calculator, there are 3 buttons on your calculator. Second, bars, and you're looking for normal, CDF, normal, PDF, and inverse norm. Those are the 3 buttons we're going to be using in Chapter 7. What do they do? Well, PDF is just like before. That's precise. That's exact. CDF is like a range. And inverse norm is when you're given an area and you want to find the z-score. Okay, now again, we're going to go over these, so you're okay. So somebody tell me, what am I trying to find? I'm trying to find a range from 1.2 to where? 9999. I'm trying to find this orange area. So what I need to do, I need to go in normal CDF. So watch what I do here. Go to your calculator. I'm going to make it big where everybody can see it. even the divas.
Ah.
So I'm going to hit second, vars, normal, CDF. And look at there, it's already got 9999 because that's what I do, but it's got the wrong one. Our lower value is 1.2. Why did I pick 1.2? Because I read from left to right. And the orange area starts at what?
Oh, shit.
The orange area starts where? I want somebody to tell me.
1.2.
1.2, and we read from left to right, so 1.2 to 9999. So your upper area is 9999. You can put 5 of them in there if you want to.
You know, my calculator looks different.
Yours would probably do parentheses 1.2, comma, right, 1.2, comma, 9999. Close parentheses and hit enter.
I got another one of them damn scientific methods.
Okay, do it again. 1.2, comma, 9999. Now, what did we say was going to be the answer? We said it'd be around 13%, right? What did it come up to be? About 12%, 11.51.
1.2, comma.
Comma, 9999, close parentheses.
I'm getting 0.
And you did normal CDF. You got normal PDF.
Oh my God. Thought it said CDF. 1.2, comma,
Comma.
9999, close parenthesis. Okay.
Got it?
All right. Yeah.
All right. So the orange area came out to be 0.1151. Now we have just found the area that's in orange. It's 11.51% or 0.1151 area or 0.1151 probability. Now that's how you find it when it's greater than. Okay, let's do another one. Okay.
You say that like this is exciting.
Well, it is when you find an area under a curve, which is very advanced mathematics.
I don't want to be advanced. I want to be beginner.
How about you can say, I passed a class that was advanced, and it does your confidence good. All right, 0, 1, 2, 3, -1, -2, -3, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Okay, and of course, I would color it green, but I think I'm just going to color the pink because I think y'all got that by now. I hope you do. If you don't, you ain't going to get it by now because I've been doing this for 14, 15 weeks, 4 to 13, 12, somewhere in there. All right, there is the unusuals. Now, I want you to tell me the area between, I'm going to do it in orange, -0.8 and 1.5. But first, we're going to do it with what? The empirical rule. So here's the area that I want to measure. So let's see, 34, this dips into that 34. So that I'm going to say that's 32, 31%, 34%. This is close to half. What's half of 13.5? What's half of $13.50? $6.75. So I'm going to do $6.75. So my empirical rule guess is 31 to 65, 71.75. I'm going to say 72%. 0.7200 or 72%. That's my empirical rule guess. Now I want you to take your handy dandy calculator
come from?
and do normal, CDF, and then I want you to figure the lower bound and the upper bound. What was your question?
Where are all, I don't understand where all these numbers are coming from.
The empirical rule. 34.
No, I've got the 34 and the I've got the percentages, but where does the 31, the 34, the 6.75 and all that coming from? I'm not understanding how you're
Where
doing
is the
that.
orange line?
At -8.
Okay. Is that all the way to -1?
No.
All the way to -1 is 34%. So what am I saying the orange is? From this line to this line is 34%.
So you take 34 and subtract -0.8?
No, I'm guesstimating. You could say 30, you could say 31, you could say even 32. But that's as far as I would go, because this is a gap right here that's probably 1 or 2%. This is a gap. What is 1.5? It's halfway between 1 and 2, right? Is 1.5 between 1 and 2? Yes or no?
Yes.
Miss Kidd?
Yeah, I guess.
You're telling me you don't know what's between 1 and 2?
Yeah, 1.5.
Okay. So if 1.5 is between 1 and 2, then I can take half of 13.5. What's 13.5? What's half of 13.5?
6.75.
That's where I'm getting those numbers. It's estimating. You're estimating this orange area.
Now, where did you get the 72% from?
I added all these up.
Okay.
31 and 34 and 6.75. Now, I'll do it on the calculator with you. Watch this, y'all.
Normal.
Learn this in the war. Second, enter. Look at there. It's already there. All you got to do is type it in. But if you got an older calculator, you don't have to. It's already there. But anyway, I'm going to go 0, -0.8, comma. Already got the comma there. And then what's my upper value? 1 point what?
5.
1.5. And then I'm just going to hit delete, 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 delete. There we go. And hit enter.
-0.056.
Check it again.
I put the damn thing in there right.
That's what I got.
You probably didn't make sure you use this negative right here
Normal
for your
CDF.
-0.8.
-0.8.
Comma 1.5.
Comma 0, comma 1.
Well, you don't need to put. Do you need to put that in yours? I don't think you do. You just hit Z. You just hit parenthesis after the 1.5.
All right.
You get it?
Yeah.
Don't be so happy. 0.7213. What did we say it was going to be?
It's 0.7213.
You said 0.7200. So I got it pretty what? I got it pretty close.
Close.
But this is your answer. The calculator puts out the answer. There it is. All right, let's do one more. Here is another one.
Yeah.
0, 1, 2, 3, -1, -2, -3. And I want you to tell me the area below. I want to know the area below 0.23, which 23 probably is right in there. So somebody tell me what's below, to the left or to the right?
The left.
To the left. So you got to find that area with the calculator this way. And while you're working, I'm going to do the empirical rule just so I can check it. So that's 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And I'm going to do this in a kind of a bluish color. I want to be different. You know what kind of Christmas lights I can't stand?
Blue ones.
Blue ones. I wish somebody would tell me what that means. I cannot stand blue Christmas lights. And I have no idea why I hate blue Christmas lights.
What, did they make you feel sad?
No, I don't like them. I can't look at them. I don't like them. I think it's something to do with my childhood. Evidently, my dad or my mom decided to, do the Christmas tree in all blue lights or something. And I got a whipping or something. I don't know. Something must be negatively associated with blue Christmas lights.
I got like 50%.
Well, you're very close. Why? Look at, what's this? What's this right here?
That's your 50% line.
So it's going to be a little bit more than 50%. Good job. I'm going to do it by the empirical rule first. So I'm going to do.
That's what I did.
Good. That's good.
I did. I added up all the percentages, and that's how I got 50. I hadn't even did the CDF thing yet.
Good. 13.5, 34. And I'm going to say, since this is 0.2, that's the fifth of 34. 34 divided by 5 is 7. So I'm going to say that's 7%. So add up, let's see, 34 and 7 is 41, 54, 57, 56, 57. I got 57%. What did y'all get when y'all did the empirical rule? What did you get, Miss Kidd?
50.
Okay, I got around 57%. So let's go to our negative 9999 to 0.23. So let's take our normal CDF, second bars. I'm just starting from the beginning. Normal CDF, negative 99999 to 0.2 what? and paste and close parentheses if you got a holder. And I got 59%. Good job. 0.59, technically 0.5910. 0.5910. So let's look what I did. I said 57% and what is 59%. Now, why am I doing the empirical rule? Well, let's say you got 57% and it came out to be 32%. If your calculator put out 32% and you got an empirical rule of 57%, what does that tell you?
You were close,
You've done something what?
right?
I'm not getting the right answers.
Okay, I'm going to answer this one. I'm going to ask this one more time. If you get an answer of 32% and your empirical rule says 57%, what does that tell you?
You did something wrong.
You've done something wrong. That's why you do the empirical rule with each one of these. Miss Kidd, what did you get wrong?
When I try to put it in the calculator.
Okay, it should be normal CDF,
Yeah, I got that.
negative 9999, comma, 0.23, close parentheses.
0.59 is what you got?
That's
10.
it. That's it. 0.5910. I got one more to show you. Now, what did we just do? We just did, okay, I want everybody to notice what we just did. Hold on a second. My computer just went ballistic. It just closed everybody out. I can't see anybody. Okay, there we go.
See you.
Okay. All right. What is this? What is the orange? Is that greater than or less than or between?
Greater than.
Okay, so we just did a greater than. That's a greater than. What is this one? We just found the area from here to here. Is that greater than, less than, or between?
Between.
Between. And what is this one?
It was less than.
Less than. So that is the three types of questions that they will ask you on normal CDF. Now, what is this one? You wouldn't know how to do it unless you've had this class before. What is the area, what is the z-score for the area of 0.6315? Okay, so first of all, you got to draw a picture to see what this is because you have no idea. So draw a picture. Zero, 1, 2, 3, -1, -2, -3. Somebody change this into a percent. What is that? All you got to do is move the decimal place 2 places to the right.
63.15.
63%. I'm just going to say 63%. Close to 63%. Okay, somebody tell me where 50% is.
Right dead smack in the middle.
Okay, so let me do this right quick. 0.15, 0.35. I'm sorry, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Now you just said, both of y'all, 2 of y'all, just said this is 50%. So 50% falls at 0. Does everybody understand that?
Yeah.
We don't need 50%. What do we need? 63%. So we got to add 13%. How can we do that? Well, we got 34 right here. What's half of 34? 17, Hubert. That's right, class.
I just said 17.
Okay, good. So 17 is at 0.5. So that's 17 here and 17 here. So what's 50 plus 17?
67.
67.
What'd you say?
Wow, that's getting close.
What did you say?
Y'all said 67.
No, you said 34 plus 17, right?
No, yeah, I said 50 plus 17, and y'all said 67.
Yeah, that's not dead on.
Well, that's close. We need 63, but let's see if we can get a little closer. What's half of 17? Now, we're not building the rockets. We're not building the rocket, okay? So just tell me what's half of 17 close.
8.5.
8 is good. So we're going to do 8 right here. That's 0.25. And 8 right here. I'm just doing it just to fill everything up. So we got 8% here, 8% here, 8% here, and 8% here. Now I know that's 32, but what am I doing here? Am I building O-rings for the space shuttle, or am I estimating? I'm estimating. So what is 50 plus 8?
58.
58.
So between 58, this is 58 right here, and 60, so we said 67, boom, right in the middle. There is 63% right there, and it's between 0.25 and 0.5. Now I want y'all to think a minute. What's between 25 cent and 50 cent?
A quarter.
No, 25 cents quarter. What's between 25 cent and 50 cent? Just guesstimate. 35 cent?
Yeah.
Okay, so I'm going to
I was thinking 0.25 and 0.25 equal 50.
Well,
That's why I said a quarter.
Okay, I see. You're thinking of, okay, I see what you're thinking of. 0.35. So I am estimating by the empirical rule that my z-score is going to be around 0.35. So how do I find that with a calculator? Well, this is how you do it. Second, bars, inverse norm. Now, with your older calculator, I think it'll just be parentheses, but I'm not sure.
It is.
Okay, so here we go. I'm going to do it. You got to type in the area. Second, bars, inverse norm, and this is what yours looks like. Well, wait a minute. Area is 0.6315. That's what you type in, 0.6315. And hit paste. Yours will look something like this. Yours will say 0.6315, then close parentheses.
But where does all, wait a minute. So put
Just type in
0.6.
0.6315, close parentheses, and hit enter.
0.34.
Good. How do we know that that's right? Because what did our empirical rule say?
The z-score was 0.35.
So we know we're about right. So we've got a z-score of 0.34. That's our z-score. So that's how you use inverse norm. Now, let me go ahead and tell you this right now. Are these easy? Yes, they're very easy. Are they something that you haven't seen before? Yes. So they're going to come across to you as confusing. So I'm going to tell you right now the first thing you need to do to keep this from being confusing. Of course, only 2 of y'all are going to do this. And that is what?
Print out your,
Print out these. And if you will print these out, you will, not these, the ones that I have. I don't like these. I like the other ones.
these.
Yes, that's the ones I like. Okay? If you will print out those and you draw a picture, it will make a whole lot more sense to you. Okay? But with that being said, I want everybody this weekend to work on, I want you to read 7.1 and 7.2 because Tuesday and Thursday of next week, we're going to finish 7.1 and 7.2.
Hell, I can't even get done with 6.2. So 1 and 6.2 homework.
You will. Now, I just finished that video so if you got more questions, check out the video first, then send me the questions if you still got questions on 6.1 and 6.2. If you're finished with 6.1 and 6.2, I want you to work on and read 7.1 and 7.2. Now, you're not going to be able to do the third ones yet. The ones that look like this, you're not going to be able to do these yet. 100 and a standard deviation of 20, 120, 140, 80, and 60. You're not going to be able to do those yet because I haven't shown you yet, and I haven't given you formulas. Okay, so what I want you to do is I want you to work on a little bit of 7.1 and a little bit of 7.2. If it looks like a foreign language to you, don't do it. I want you to read and then try to work on some of the homework problems, okay? Is that fair enough? And then Tuesday, I'll help you get through 7.1 and 7.2 and do questions on 6.1 and 6.2. Everybody with me? But I have to give you a little bit so you can move on with 7.1 and 7.2. All right, who's got questions? Did anybody come late after I did? Did anybody see anybody come late? Nobody's going to talk to me now? Okay.
I didn't, I mean, I ain't.
Okay. All right, I'm not going to take the roll. They're not here. They're not here. All right, y'all have a good weekend and work on 6.1, 6.2, read 7.1, 7.2, and if you feel like it, work on the homework for 7.1. Y'all have a good night.
You too.
All right.
And don't
Bye.
stress.